we want to bring in here from the beginning. A script will provide these PKI protocols for us via the server. These PKI protocols will be downloaded from our connected CCUs, downloaded in the car, and during the connections with these PKI we will generate group keys. These group keys will also be exchanged so we can ensure that the communication inside the platoon is secure. Why? Because if the trucks are driving and we are accelerating, we have to keep that someone from outside cannot manipulate this platoon, for example, deceleration one. Another one, we want to change the group keys during driving in a regular time slot, because also it could be possible that one person from the outside can listen to data transfer. Maybe they cannot collect the data, but according to the data stream, they see if the truck driving every day the same route. Oh, okay, now is coming the blue and the yellow truck, because I see every time the same data stream. So changing the group key in security means we also can keep the privacy that from outside we keep anonymous driving. Now they will smoothly pass, let's say, the corner on the highway. Of course, they will not stop. That's why they are driving through. And after they will smoothly again accelerate again, but due to the short distance.
So I would very much like to thank our partners from CONCORDA for giving us the opportunity to do this demo one more time here today. What we would like to show you today is roadside assisted connected driving. So we will demonstrate how autonomous vehicles can benefit from roadside assistance, or from information coming from roadside sensors. So the use case for this is that vehicles, automated vehicles, have great potential in increasing safety, but there's a limitation to what their sensors can see. So the typical range is less than 200 meters, and obstructions like buildings in an urban environment will disrupt the line of sight, causing them to have less situational awareness. So today we will demonstrate how roadside sensors with communication can actually enhance this experience by already earlier providing information to the vehicle. Because the roadside sensors will have a beyond line of sight, let's say, field of view, and provide information to the automated vehicle a lot sooner. And this will increase the safety, make the traffic flow a lot smoother as well, and increase the comfort for the passengers. So we will demonstrate this with 3 different scenarios today. And the first one, we will actually not have communication to the roadside sensor. So actually the roadside sensor is located on the light post you see over there, which consists of a radar and a communication unit. And in this first scenario, we will have an automated vehicle following a predefined path to take a right-hand corner. And a second vehicle will be following with longitudinal adaptive cruise control. And there is communication between the vehicles, so the following vehicle will know already what the front vehicle is going to do. To develop this demonstration, we first started off in our simulation software, SimCenter Prescan, which is a tool to simulate the sensor and world environment of an automated vehicle. And actually using this, we can already develop the algorithms before we go outside into the real world, let's say. Living test lab, which is operated in full by Siemens. So all of the cameras and all of the sensors equipped on the highway from Helmond to Eindhoven, they operate to gather information on the traffic flow here. It's also, the site is fully equipped with ITS G5 communication technology. And next to that, recently KPN has opened their 5G test field lab here to connect. Alright, so we see the vehicles approaching now. Vehicles are giving a priority request, but actually, because we have no communication to the roadside unit at this moment, they will slow down quite steeply and take the corner extremely slowly. So as you can see, this results in safe behavior, but not necessarily efficient behavior. So this is quite annoying maybe to persons behind you, because you don't know why the automated vehicle is braking, because the road is actually clear. So vehicles are ready now for the second approach. Remember, now we do have roadside communication. As the vehicles start approaching, at some point the pedestrian will also start approaching the intersection. It's safety zone, so we do not want any objects to be in the safety zone. And now we see the detection has picked up. There's an object in our safety zone. The vehicles brake well ahead of the corner to avoid unsafe situations for the pedestrians. And now, as the pedestrian moonwalks out of the safety zone, we will see that the vehicle will actually proceed its maneuver safely again after the road is clear. So we'll see the third and final approach. Again, we see all the status information of our intersection. Vehicles are approaching. We will again give a priority request to the traffic light to turn turn green. And it's a bit difficult to see the difference in the sensor feed, but because there's a communication established between the roadside unit and the vehicle knows that it's safe to cross, so it's aware that there's actually nothing in its path around the corner. And this will result in a smooth experience for the driver. So we see smooth behavior, no unnecessary braking, nobody behind you will be interfered. So now the automated vehicle is much more aware of its surroundings.
Well, I want to congratulate all the partners at CONCORDA for a job well done. Today we saw for the first time a big demonstration showcasing what CONCORDA is all about. And at the end of the day, it's all about increasing safety for people, safety for drivers, safety for pedestrians. And I think what we have seen today is that the technology has advanced a lot, thanks in fact to the collaboration and the cooperation of different partners from different sectors. And that's at the end of the day what it's all about. That's going to be the future of mobility. That's going to be the future also for the automotive industry, working more closely together with other partners to make things happen. And CONCORDA is a great success model and an example of what can be done and what can be delivered. So, well done.
We just gave a demonstration of the CONCORDA Siemens demonstrator, where we demonstrate the communication that we developed together with KPN in the CONCORDA project, and together with other partners to build a very nice demonstration on corporate connected driving in the urban environment. Today we presented our first installation of the truck platooning from the CONCORDA project with 2 trucks. The focus of the CONCORDA project is to working together with the mobile network operator to check the V2V communication and V2X communication on 2 different technologies, the ITSG5 and the cellular V2X. And with the communication through the mobile edge computing, we want to check if we have a redundant communication part, if in the V2V communication we have some interruption or disturbances.
In Belgium we are also deploying our testbed for automated mobility and connected mobility. So we are first of all providing a lot of connectivity, short range, long range, hybrid communication and so on. And we want to support different use cases, mainly based on the highway chauffeur. We already demonstrated an emergency brake light use case very recently, and now we will also further work on more cooperative awareness use cases as well.
So today we did a demonstration for CONCORDA
in the Pilot Noord-Brabant, we are working together with Siemens, TU Eindhoven and KPN to show connected driving with vehicles, two use cases, CACC and automated intersection crossing, where the vehicles are connected towards via our mobile network to the edge and can also communicate to each other through short range. And we're testing out different communication technologies in combination with the use cases CACC and automated intersection crossing.